Welcome everybody. In this video, we are going to talk about structured data types for IGCSE, okay? Or simply structured data types. Starting our discussion about this, okay, we will just talk about a problem, okay? If we are using only simple variables for our program, so it is perfect for storing single pieces of information. But think about this, okay? If you're writing a program to manage scores for 10,000 students, for 10,000 players, okay? And you want to just create variables for each one of them. So this is inefficient, right? Or writing code for 1,000 variables or creating 1,000 variables, that is error prone, and mathematically as well, it's impossible to manage them with loops, okay? So we cannot work with very large number of data with the variables only, okay? So what is the solution? The solution is we will just simply use some data structures, okay? And simply data structures allow us to group, organize, and process massive amount of related data under a single identifier. So already they have created different systems and methods that we can organize our data. And then we can use loops very easily to just work on those data, okay? So that is just data structures. And we will be introduced with some very basic data structures or methods of solving this big problem, okay? So what are data structures? A specialized way of storing and organizing data items so they can be processed efficiently by an algorithm, okay? So why use them? Simple variables like integers or strings hold only one value. Data structures allow managing large related data sets under a single identifier name. So they are just good for efficiency, for searching and sorting and things like that. They are very good. Then maintainability, they are just much cleaner. Instead of writing 10,000 names for variables, I'll just simply use one name, okay, and write my code, okay. So this is much cleaner and more modular code, okay. And it maps digital data to physical groups, okay, student rosters, group of students, list of players, things like that, okay. So we can work with them very well. And in the types of that, okay, first of all, we are going to talk about arrays, and inside arrays is a one-dimensional array, okay. So array is like a linear list, a structure storing multiple items of the exact same data type, homogeneous, under a single identifier. So see, if this is text, the next one is text, the next one is text, okay. So if all of them are the same data type, one is a number, all of them are numbers, one is a string, all are a string, okay. So that is an array. And simply, how can we just get or access different elements in this array, okay. So each array can have a name. For example, name of this array can be names. So names, then after that, each element has gotten an index starting from 0, okay. So names index 0 is Alice, or names index 3 is Raja. And if I change the variable as well, okay, so names index 3 is equal to Sahil. So instead of Raja, we will just have Sahil there, okay. So remember one thing, the golden rule, okay, always indexes start from 0, okay, do not forget that. Then anatomy of arrays, simple what we have here, okay, is set names, see, index 1, then for example index 2, okay, set names index 1 to Fred. So first David is here, David will be removed and Fred will be just there, okay. So see, we have gotten this name of the array, then inside the square bracket the index of that, and we can just work with that like a variable. We can just read data from that or change its data, okay. So assigning values, use bracket notations to pinpoint an exact address, then assign the new value. So as we can see there, okay. And finding the size, for example, a list is given to us, an array is given to us, and we simply want to know what is the size of that, how many different elements are inside that, okay. So we can just use that with length. For example, name of this is names, so length names, this will return 4 to us. Right now we have gotten only Alice, David, Orla, and Sarah. So 4 elements. That will return 4 to us. And the linear search, although in future we will just study that in depth, but here simple linear search, okay, that is we will look, if we are looking for any value inside an array, what we can do is one by one we can just check it with the help of the indexes. Okay, so index starts from 0, so we will start from 0 and then 1, then 2, then 3, and we can traverse through the elements of an array one by one and do our comparisons. Okay, so traverse the list using a loop, comparing each element with the target. State flag, so simply we will have a variable named found, and simply if our data is found we will change it to true, otherwise it will just remain false. Okay, and see the example. For I from 0 to length scores -1, because this last index is always 1 less than the length, because index starts from 0. Okay, now 6 elements, but the highest index is 5, so 6 minus 1, so that's why. Okay, from 0 up to length of the scores -1. Okay, instead of this score you can just write the name of the array. So if scores, see inside that array, index I, which starts first, it is 1 0, then 1, then 2, is equal to target, then set found to true, end if, so it ends here. Then after that, next I, or I is equal to I plus 1. Okay, so next I. So that is an example for linear search or traversing through arrays. Then the next thing that here we are going to talk about is two-dimensional arrays. Okay, two-dimensional arrays or grids. Very simple, if I just tell you two-dimensional arrays or arrays of arrays. Okay, we have got an array with multiple rows inside it. Okay, each row of this table is one element of our main array, and after that each element is an array by itself. Okay, so when a simple list isn't enough, we expand into a grid like a chessboard or a spreadsheet. It is essentially an array of arrays. And coordinating that, yeah, which cell do you need? Okay, which element do you need? Then yeah, we can use two different indexes there. Okay, so see, target, if I want this, the name of this is grid. Okay, grid. Then inside this square brackets, instead of one value, we have gotten two values. The first one is row number, so that is 2, and the second one is column index. Okay, and that is just our column index. Clear? So that is just the way how we access elements of 2D arrays. And navigating through 2D arrays is with nested loop. Okay, one loop will just go through the rows, the first row, then the second row, then the third row. Then inside that we will just simply have another loop that will just go through elements of that row one by one. Okay, so our outer loop can be just at 0, then inner loop can start from 0, then 1, then 2, then 3. Then after that our outer loop can just go to 1, then again our inner loop can start from 0, then 1, then 2, then 3. Okay, and it can just go like that. So that's it. Okay, the inner loop runs completely from start to finish, checking every column in a single highway. Okay, something like that. And the outer loop ticks forward by exactly 1 moving to the next hallway. Okay, or just to the next row, only after inner loop finishes. So inner loop, if just gets to the end, then our outer loop gets to the another number. Then our inner loop starts one by one, goes through the first to the end, then our outer loop will just go one row higher. Okay, so we have just gotten this. Then now the thing is, okay, in real world, not everything that we work on, okay, or every data that we work on is homogeneous. Okay, it means same data type. We can have just different data types about one thing in one unit. Okay, so what is that? We just do that in computer science with records. Okay, see, arrays, they are homogeneous. They cannot accurately model real world entities. Only one exact data type is allowed in the entire structure. This is just good for lists of numbers, list of names, things like that. But for example, a custom data structure containing a collection of related items called fields, which can be of completely different data types. Name of this person is Alex. Then age is, for example, integer. Then is he a student of our institute or not? That is just kind of Boolean. Okay, so we can have different data types inside a record. Okay, so that is what we have to just discuss. Or see in tables, for example, we can just say tables or arrays of records. Okay, so each row is an element of an array. Then each row itself, because it contains different data types, it can be a record. Okay, so 1 Sarah Jenkins 11. Okay, then the third one. So we have gotten, see, each row of the table is known as a record. Okay, so this is a record, the next one is a record. Okay, and different data types out there. Then each column of a table is called field. Okay, field is one variable that just simply gives a specific information about that entity or that record. Okay, so that is just what you have to know. Then accessing data inside records. See, we access data inside arrays with their index. Then if that is just inside a row, okay, or inside a record, then we just simply, each data can have its own name. Okay, or each field can have its own name. So with dot, the name of the field, we can just use that. Okay, so see here, student 1, that will just get this complete record. Then from that student 1, I want to just get the name, so dot name, so that will be just the name. Okay, by the way, that's name of the column. So that is just how you can get, okay, you can get well, elements of a record with dot. Okay, so that is exam success hacks, things that you have to be careful about in the exam. Okay, the first one, index out of range, that will just cost you number. If the length of your array is 5, the highest index is 4. If you, and the lowest is 0, so you can just give index to it from 0 up to 4. If you just give any value or any index to it outside this range, you will have just index out of range. Okay, so remember that. Then when you are just coding, try to write extensible code. For example, do this from 0 up to 10, because right now our array has gotten 10 elements, okay, or 11 elements. Okay, do not do that. Instead of that number, always use the length function. So if the length of your array changes, as well, this code can just run. Okay, so that is extensible code. If right now it's 10, as well it will work, because length of array will just simply generate 10. If it becomes 2000 as well, simply it will work. Okay, so the matrix for array and record, in array data types has to be the same, but in records we can have just mixed data types. Then we can just simply access arrays or array elements by the index, and the records by field name or just index. Okay, dot, then field name. Then arrays are best for lists, grid, math, things like that, and records are just best for profiles or database rows. Okay, or table rows. Practice zone, some questions are there. Okay, define what makes a record different from a 1D array. That can be an exam question. Okay, record holds mixed data types, arrays holds only one. The next question, okay, write the pseudocode to assign the value winner to the top right cell of 3x3. Okay, so we have top right 3. Okay, so that is, if this is 3, so indexes are 0, 1, 2, then this one is also 0, 1, 2. So this is in row 0, then index 2. Okay, so set grade 0 to 2 winner. And the next question, why is a while loop sometimes better than a for loop when searching a 1D array? So that can be, okay, a while loop can stop immediately once the target is found, avoiding unnecessary checks. Okay, we will just discuss more about this. See here, if we just use index, simply, yeah, here I'm just making found variable. Okay, whenever this becomes true, so not true will be false, and just simply this will this code will be terminated. Okay, so we are not doing something extra, but here manually I have to just write a break. So that's why while is a little bit better for searching. A while loop can stop immediately once the target is found, avoiding unnecessary checks. That's it. Wish you all the best. Good luck and goodbye. Like and subscribe our channel. Okay, that